Hey, Warren, how are you? And Chris. Hey, tell me how the audio is. It's kind of noisy in here right now. Hey, Max is here. Hey, Max. Tibor, welcome. Titus the Great. Pert Nearly Machining. Well, you guys are like on it today. Mr. Blodgett, welcome aboard. It's okay. Audio is just okay. Hey, GLG Knife Works, John, welcome aboard. I don't know, you guys. This 1 o'clock time might be the right thing. Thank you, almost. Can I call you Al? Indiana John. Archibald, C. Archibald, or is it Carchibald? I don't know. Yeah, it may be a better time, so we'll see. We'll take a vote at the end here. Hey, man. Strangely enough, John, there are very few people who I would say this to. I would be your bodyguard, just so I can call you out. So happy Sunday. Happy Sunday at 1 p.m., an hour after the local noon here. But I had to take my kiddo down to Boston. Greetings, Tibor. I had to take my kiddo down to Boston and back, which I did, and that was just not going to work for noon. So we may have tripped over a better time. We got more and more immediate check-ins now than we did last time. So if that holds. Ah, okay. Oh, so it's like a family affair. Indiana John and C. Archibald, welcome. We like family business here. So Warren, if there's any significant reasons why not to do it at 1300, let me know. So yeah, welcome everyone. So it looks like Thanksgiving is like knocking on our door here. I'll be doing that Boston round trip probably on Thursday morning or Wednesday or something. I don't remember when. I think it's Tuesday. Who knows? Anyway, welcome. The shop's been a little quiet in the last couple of days. We've been doing a lot of winterizing and domestic things, but that's all cool. I did have some communications with Adam the machinist, Adam Demuth, and I don't know if he's going to be on with us today. Ah, cool, Titus. Well, thanks for checking in. Appreciate you being here. Mosen, welcome. So yeah, Adam Demuth checked in with me on messaging, and we talked. Thanks, Warren. We talked about the little stones, which I have dubbed the roundels. So now we have the minis and the roundels, and they are cute as a button, 2 inches in diameter. And the first set, of course, went directly to Adam because he was the one that came up with the need. And the good news is he likes them. Hey, Mikey. So he said, one thing he said that was pretty interesting. He said that the hole is pretty nice place to put your finger. And typically, because you're down in a cavity and you're trying to use the stone down in a cavity, so that was interesting. So far he likes them, and if Adam the machinist likes them, I'm okay with that. Fad Radcator, welcome. So the roundels are a thing. I put them up on the website. I priced them a little under the minis. So they are now actually the least expensive PFG stones on the lineup. And one of the reasons I brought it up today first is that another thing happened today, or not today, this week. Actually, it was yesterday, where Chris, the pragmatic machinist, and I were messaging about scaling something in Fusion 360. And I think I directed him to the right place in Fusion 360 for doing scaling. And then, but he also asked for a snide remark, so I told him that all he really had to do is look at his parts backwards through binoculars, and when they look small, they'll be scaled. So, but I want to show you something, except that a question just came in, and I have a bad feeling about this. What diameter are they? Okay, so that wasn't the question I was fearing. These are 2 inches in diameter and a 1/2 inch thick. At least that's nominal before PFG processing. So this is a raw stone. This has not been ground yet. Yeah, it's 2 inches in diameter, and it's a tad over, and it's a 1/2 inch thick. So these will lose about 40 thousandths after my processing. So they'd be 40 thousandths below a 1/2 inch thick, etc. But let me tell a story here. So I think I answered your question. Let me tell the story about the scaling. I saw the question come in. So Chris says, how do you scale? So you scale in Fusion by going to modify, the modify menu, and then there's a scale. So this is the tray for the 4-inch round stones. And I took some liberties with making it pretty cool, and it is pretty cool. And we needed a tray for the 2-inch round stones. So what did I do? I took this design in Fusion and I scaled it by a factor of 2 or a factor of 0.5. And there it is. So these are not perfect because the stones are a teeny bit bigger. So I'm actually going to be making a modification. But for the stones that I sent Adam, these trays were totally usable, and I made a couple of them, and I sent the stones off to him in these trays. So Chris, this is an example of a direct scale. So every dimension on this is scaled 50%, and it worked great. So again, I'm going to make a couple of little adjustments on the roundel tray. Hanji, welcome. But I wanted to show you that. So Fusion 360 scale, it works. And you can do weird things too. You could just scale one axis or 2 axes or 3 axes, and it's pretty cool. So what I'll probably do on these is just go back and change the scale factor like 0.5% bigger, and that I'll do some math before that, and then these guys should be just fine. Okay, so that was the commentary on scaling, and I think I told you the roundels are on the site. I don't remember the price. I want to say $129, but they're there. Meyer Tooling, welcome. I think this is the first time for you. Okay, so another question came in, which I think I might be sorry about this. Is a conflagration of an excrement-filled parchment container placed upon one's vestibule suitable punishment for someone posting Mariah Carey Christmas music to their Instagram stories? And if so, who in your area wants to make $20? Okay, so first I have to explain, there's some people that do not understand the holiday significance of an excrement-filled parchment container. But, you know, I grew up in Brooklyn, and we just called them bags of shit. So I don't know what you're talking about, Chris. But and then, of course, you would set it on fire. So whoever opened the door would have to stamp it out. And now you got the excrement in the bag. So Warren's your guy. Warren's in. Warren is in my area and wants to make 20 bucks carefully placing a flaming bag of shit. Now, the funny thing is I played bass for Flaming Bag of Shit back in the 80s. It's true. Well, you're right, Chris. That was bizarre in the extreme. But what I want to know is who is playing Mariah Carey Christmas music on their Instagram. So if you don't want to say it publicly, just PM me. Well, I don't think I could be the one placing the flaming parchment container. I am definitely a fan. So, I didn't mean to go off on... Oh no, really? Well, he's here to take the abuse. You could just abuse him directly. You guys, now I know why I like you. Okay, so those of you who are across the pond, as it were, you may be shaking your head, wondering what all the hubbub is about. Don't worry about it. It's really not important, but it is, however, very funny. So, okay, that's pretty funny. I don't have any progress to report on our resources page, which is sort of what I'm calling our book list, but it's coming. I'll let you know, promise. A couple new sign-ins here. Is that Ali for short? I don't know. Welcome aboard. And a name that I'm not going to try to pronounce, but welcome aboard. So, yeah, the resources page is coming. If you guys think up any questions you want us to talk about today, start getting them in the question box. Or if you don't have the question button at the bottom, like if you're not on a phone and you don't have the question button, it's okay to put it in the chat. We'll try to jump on it. Grinder is warmed up. We've got some work to do. I'll show you. So there's my afternoon's work. We got four 6 inchers, or 2 sets of 6 inchers, 2 sets of 4 inchers, and 2 sets of minis in the pipeline. So that's what I've got to get done. Mr. Grinder is just warmed up, and I think I did enough. Morning chores that I can spend the rest of the afternoon grinding. So we'll try to get that done. So last order that was shipped out was Canada. Thank you, Canada. I don't know if you're in the chat here or not, but thank you. Appreciate it. Oh, and I have to follow. I have to take some homework. I just remembered. We had an order from South Korea, and I need to check on if it landed. So we'll see about that. So we have somebody checked in that's just a whole bunch of numbers. And golly, who are you? Anyway, what else is going on this week? What are you guys doing? What are you guys working on? And are there any other random engineering or machining topics that we're going to end up diving into? I wanted to give a shout out to John Saunders, who's not here, unless he's in disguise. He said something a couple of weeks ago in one of his videos, about using the powder coating masking tape that he discovered on McMaster, which is the green stuff here. Fat Rat Cater's putting in a new hot water heater. I don't wish that on anyone, brother. Don't solder those joints, by the way. TIG them. It'll hold better. So anyway, John came up with the idea of, if you put a Sharpie note on something, putting a piece of the green powder coating masking tape over it. And I took that to heart, and I think it's awesome. So now this is as good as forever. This will never rub off. This tape is glorious. And this is one of my gauges for setting my sine table to 45 degrees. There you go. Warren is plumbing, scrapping old cars and junk, and home repair. No shop work. Yeah, well, there's going to be a lot of home stuff this week for sure. Let's see, we got another question popping in. Oh, yeah. That's a great question. Yeah, let me get you that McMaster number, KR, and then we'll go on to the question. Hold on one second. So this will be a two-way tip, okay? The other part of that tip is always do what I'm about to show you. So if you buy something from McMaster like this, write the McMaster number on it, okay? And then you won't ever have to wonder where it came from. So let me read this to you because I know this is backwards, right? So get your pencil ready. 7630 Alpha 23. One more time. 7630 Alpha 23. There you go. And it's just great stuff in general. It must be a polyester because it has to handle the heat, so it's probably some really cool formulation. But this tape also has another interesting property. It's 3.5 mils. So this is really useful. I use it in grinding. Yeah, of course you can search on McMaster orders after ordering. Absolutely true. But, they're not going to label it for you with their number, right? But you will. So, yeah, a lot of little tips coming up this morning. SolidWorks house, welcome. I am a SolidWorks seat. Welcome aboard. Yeah, I go both ways, SolidWorks and Fusion 360. Don't judge me. So welcome. Let's see. I think are we cleared to go into the surface grinding, surfacing a mag chuck? Okay, so I remember, I have gray hair, so I can say this. I remember when I had my Harrig. I had my Harrig 612, and this was my first grinder, all manual. It's still working. Ducky has it up in Maine. And I did my first chuck grind in, and I went to school on that project. One of the big challenges is that a chuck. Can we bring it into the picture? Oh, excellent. Mr. Blodgett, you're picking up on things. You're completely correct also. So grinding in the chuck is a challenge, and one of the reasons it's a challenge is that the materials used in a magnetic chuck are soft materials. So it could be stainless steel, it could be aluminum, it could be brass, in addition to a mild steel, which is usually a soft steel. So the reason for that, if you play with magnets, I just happen to have some magnets around here. if you actually, let's do it a different way. If you play with magnets and steel, everybody knows that, you know, this is a scriber with a magnet on it. Everybody knows that, you know, steel is magnetic, right? But stainless steel, I'm not even going to get out of my chair. Stainless steel, it says right there, made in USA, stainless steel. Stainless steel, oh, this is slightly magnetic. So this is like really weakly magnetic. Okay? So we know that this is probably a 400 series stainless. And if we get something that's full stainless, which I'd have to get out of my chair. This is brass. I know this is brass, right? Nothing. So the way they make a magnetic chuck is they have fingers of a magnetic material like a mild steel, and they have fingers of a non-magnetic material like aluminum, stainless, brass. Let me grab something for show and tell. Hold on. Okay, I'm back. So here is a magnetic block, right? So this is nice because you can see the darker material is steel and the lighter material is aluminum. And if I take by the way, don't feel bad. This has not been ground by me yet. So this is in the projects box. So if I take my scriber and I just kind of touch it, it's very obvious that one is steel and one is aluminum. Okay? So that's how your chuck is made. And then actually there is a magnet on the bottom where typically if you use a manual one, right, you throw the lever and it takes a magnet and it basically lines them up with the steel, and now the magnetic lines of flux come up to the top, and then it will move it a different way and it will actually short the lines of flux, and now it turns off the magnet. So that's how it works. It's very important to understand how it works because to understand what you're dealing with. So having said all that, and then this one here, I don't know if you can see it. Can you see it? This is an electric, it's an electromagnetic chuck. So there's actually a control, there's a knob on the control that will turn on a current going through a coil of wire inside the chuck to do the same job. But at the surface of the chuck, right? At the surface of the chuck, they're all the same. It's alternating magnetic material and non-magnetic material. It's always soft material. Okay, that's the big, hey, CMS NH, neighbor, welcome aboard. So it's a soft material, so you're grinding a soft material, and therein lies the rub. Hey, I like what I just did. So if you're going to grind a chuck, I'm going to grab. I should have a raw wheel around here, but I don't. They're all used. So this is a white grinding wheel. So in Norton land, we call this a 38A material. Okay, this is the simplest chemistry. Yeah, Indiana John. They're very complicated to get this to work. It's not as simple as the magnet pulls away. That's not what it is. They're literally shorting the flux with a piece of steel. They're shunting the flux away from the pieces that go up. It's actually pretty cool stuff. There are resources on YouTube of people who have taken them apart. I will not dive into that. It's not important for us right now. So you got soft material, and you're trying to grind the soft material. The biggest problem if you're doing this on a manual grinder is going to be patience. You cannot take a heavy cut because the material will load up your wheel, okay? This wheel, when it was new, was completely white, and now it's got dark spots in it. And those dark spots are soft material that loaded up the wheel. So I would have to dress this wheel down probably 20 thousandths or well, 10 thousandths anyway, to get back to white. Now, it's not hurting anything at the moment, but you just have to understand that it's loading up. So when you go to grind that soft material, and if it loads up the wheel, it's literally going to stop grinding. It's going to start rubbing the soft material that got caught in the wheel. Let's just call it aluminum. It could be brass or something else. Is going to now start rubbing on the wheel, perhaps in addition to cutting. So it's not a switch. It's not all of a sudden it's cutting and now all of a sudden it's rubbing. There's a curve. And what will happen is you'll start cutting less because it's going to put more wheel pressure on your machine. All right, and your machine, right? You got your wheel here. It's a C frame, right? Your machine is literally going to bend out of the way due to the additional pressure. Everything is pasta, okay? So even your grinding machine, your surface grinder, which is a grinding machine, is bending. Everything's bending. It's always bending. So you start loading up the wheel, and now you're putting more pressure on the wheel, and it literally is bending your wheel out of the way. So what does this mean? I remember this really well. My first attempt at grinding a chuck, I had 4/10 difference between the back of the chuck and the front of the chuck. And the clue was I started at the back and I stopped at the front. So eventually I figured out that I was loading up the wheel. So now, once you realize that, everything you do has to do with how do you not load up the wheel. So there's a couple of things you can do, and it's like anything else. There's style points for how you go about this. The first thing is you can't take a big cut, because whatever cut you take, you want your coolant to be able to wash away. So the first thing you heard out of my mouth is coolant. You need coolant. Now, again, when I had the Harrig, I didn't have any flood coolant. So my coolant, based on reading, and reading everything I could, I ended up using Crisco. So I took Crisco and I would wipe the chuck with Crisco, and that was before I had a Noga Mini Cool. So all I used was Crisco, very a light coating, so you see it, but it's not, you're not glopping it on. So that lubricant helped immensely, and that helps prevent the wheel from loading up. So that was one of the first things that helped. The second thing that helped is never take more than 2/10 down feed, and that'll help you avoid loading up. 1/10 is fine, but again, on a manual machine, you're going to drive yourself nuts. If you have an automatic machine, it's way easier. So you need a lubricant. I graduated from Crisco to the Noga Mini Cool with Cool Mist 78. I think I started with 77 and went to 78. They're fine. Yeah. So Fadrad Cater says he saw an old timer who used tallow. There's not much difference between tallow and Crisco. Maybe tallow might be a little thicker, but it doesn't matter. In that thin layer and with the heat that's going to be generated, it doesn't matter. However, those are the things. So you're taking 1/10, maybe 2/10. You've got a lubricant. You dress your wheel with what we call a fast dress. So what that means is you take your you take your diamond, okay, and you put that on the table. And again, I'll reference this to a manual machine. And when you run your wheel across the diamond, you basically run it like this. See how fast my hand's going? That's fast, okay? You run it across the wheel. So what happens is you'll dress the wheel, and you can do that a couple of times, right? So you're going to end up dressing the wheel, but you're going to say, hey, doesn't that leave kind of like a thread on the wheel? Yes. So that's called an open dress. Here's what you do not do, for contrast. You do not take your diamond and run it across your wheel slow. Because now what will happen is the face of the wheel is too smooth. So automatic feed, your Coval has automatic feed. So it's potentially useful. Let's just set that aside for the moment. Let's just make believe we're just doing this manually. Because really the rules don't change, just how you set the machine up to do it changes. So you do a fast dress, also known as an open dress. And then you go to town. Now the question is, how much step over do you use? That's another good question. A very small step over, which you might want for very excellent finish on steel, is not what you want for flat. So let's define what you want on that chuck. Do you want your chuck to look like a mirror? It's not necessary, and it's actually, you can make the argument that it's detrimental. Try to get parts off a mirror to mirror surface that is got some lubricant in it. You've got hydraulic issues trying to get it off. So you don't necessarily need a pretty surface. You need a flat surface. Big difference. So I was pulling my hair out, just saying. I was pulling my hair out, and then I found an old reference in a Norton publication from the dawn of time, which said all the things we just said, except then it said your step over should be 1/2 your wheel width. And I'm like, whoa, that's impressive. So we're now talking about a 1/10, maybe 2/10, lots of lube, and a half wheel step over, and you get across that chuck. When you look at it visually, this is not going to look like a gorgeous ground, beautiful surface. But we're not looking for a gorgeous ground, perfect surface. Once I did that, that was sort of the key for me that got me back to flat. Everything started working. So I wish Ducky was on today, because I had asked him to post a picture of the chuck I sold him, but it looked horrible, because visually you saw these very wide marks across the chuck, but it was flat as a filbert, and that was a good grind. Okay, so that's another trick, is if you're having trouble with loading it up, you can take a very big step over, half the wheel width, and get across that thing, and you'll find out that it works. Now, how do you know? There's two questions here. How do you know it's flat? And I think we know something about flat. And how do you know? How do you know you're loading up? It turns out, let me answer the second question first. If you take an indicator and you attach it to your wheel housing, and you put it down on the table, and you run it across the table after you've ground it, it doesn't matter what your ways look like. The chuck should be parallel to your ways. Okay, your ways can have a big curve in them, And now when you grind your chuck, it's just going to copy the curve. It doesn't know how to do anything else. And then when you run your indicator across it, it's going to say 0 because it copied the ways. So the question is, did you copy the ways? So that's the first question. Did you copy the ways? And if the indicator, as you run it across the chuck, reads 0, you copied your ways, okay? If your ways are flat, now your chuck is flat. So that's a separate question. If, however, you run across the chuck and you see it coming up toward the last thing you ground, you were loading up the wheel. The wheel stopped cutting and started pushing at the end of that grind. That's how you know your wheel loaded up. So there's two messages here. Number one is you've got this pretty cool method of telling if your chuck grind worked, and that is running the indicator. That's the first message. The second message is, if it reads 0, 0, you still don't know if it's flat. Okay? All you know is that it copied the ways. I can't stress that enough, because we get confused between something being flat and something just carbon copying the ways, which is really what a surface grinder does. It just copies your ways. So then if you wanted to take the next step, like if you know your ways are flat, which is a separate question, then you're done. You've done the job, and you're finished. The next thing I would do is take a file or a stone, not a PFG stone. You'll see why. And just do the corners of your chuck. Just kiss them. All right. So that if you get a little dent in the corner, it doesn't raise a burr near the edge. That's not a huge deal, but just kissing off those corners is good practice. So that's how you do. That's how you grind a chuck. So again, you said your specific question, Indiana John, was a surface grinder newbie. Okay, so everything I've said applies to a new grinder hand on a manual machine, and nothing changes after that. It's just now, okay, how do I start using automation? The first way you use automation is if you have a machine that has some automation in it, and the machine you were referring to, I don't remember what it was, that applies here. You probably have coolant. Okay, first thing is turn the coolant up to 11. Okay, you want lots of coolant on the surface. Second thing is, you can do a 1/10 cut, and maybe you might have to do, if you have a lot of crap on the surface, you might want to do 4, 5, 6 of them. You're not going to wear yourself out. Your human machine is not going to get bored. Let the machine do it if it can do it. And the other thing is, doing that half wheel step over, you could just dial that into your machine. Now, the idea of the half wheel step over, just to go back to that for a second, is specifically trading off high frequency, very, very fine structure for very big structure. You want your big structure just to be very flat, and it's not going to look great. It's not going to look pretty. Here's an example. I got kind of an example here. Let's see. Let's see if I can see that. On this sine table, you could see, I don't know if you could see it, you could see some grinding marks. I don't care, because it's flat. So that's the important thing. Okay, a bunch of questions are coming in, so let me move on. I think I've beat that one to death. Let's see. I think we did that one. Oh, Raphael, I need a translation, my friend. My Russian is terrible. So sorry, you're gonna have to translate that one for me. Yeah, somebody want to translate that one for me? Let me know. Okay, next one. All right, so this is a common question, and I would be lying to you if I told you that I was the expert on picking wheel types for materials. Absolutely not. So if Adam was here, we would ask him that question, but I know one of the things that Adam has said is, you can use a white wheel for everything. It's just a matter of, is it the best solution? So D2 is a tool steel. I think that's one of the tougher steels. 58 to 62. I have no idea. I would do the same thing that I'm going to recommend you do, which is I would hit the Norton site and see what the recommendations are. They're all gonna come back to one of a couple of types of wheels. So the first thing you have to ask yourself in wheel choice is it a ferrous material or a non-ferrous material? Or even that's not exactly accurate. Is it a steel or is it not a steel? So if it's a steel, it's going to be an aluminum oxide of some flavor. It may have some ceramic in it. Well, it's going to have some ceramic in it probably, but it's an aluminum oxide. It's not a silicon carbide. Okay? Don't even bring up CBN. That's so super specialized. Probably not what you're asking is what I'm guessing. So it's probably an aluminum oxide. So if I had to make a guess, I'd say the first thing you could start with is something like a good old white wheel. Now, what's the downside of using a boring white wheel? The downside is that it might what's the word I'm looking for? It may wear too quickly. Okay, so you might have to dress it too frequently. So that could be a downside. If you're using a wheel that's got too dense a structure or you have too fine a dress, it may burn the material, and you see that in the material. So the first thing you do if you start burning the material is you go from maybe a very fine dress with your diamond and go to a very fast dress on your diamond. Try that. So if you're still getting burning, now you got to change wheels. So one of the wheels I keep in my arsenal is one of the Radiac wheels, also known as a pink wheel, also known as a ruby wheel. And these have some wicked open structures. You see the holes? All right. Compare that. This is like Swiss cheese. So again, if you're burning, you could switch to something like that. That is probably a pretty darn good wheel for that application. After that, man, it really depends. And there's a million other things. What is the final surface finish that you need? How much patience do you have? So, yeah, I don't have anything better for you. Like I said, I'll say it again, I am not the expert on that. But I wouldn't be, if you handed me a piece of D2, I wouldn't be afraid to start doing my homework. Okay, so I hope that answers the question, or at least sidesteps it in a very amazing way. Okay, so this is a question for the group from Frad Radcater. He found a T&P tilting head surface grinder. Does anybody know anything about them? T and P. That would be, are you talking Taft Pierce? There's no and in there if it's Taft Pierce. Tilting head surface grinder. Does anybody know anything about them? Let's see if anybody comes through. But that's the question on the table. I, for one, know nothing about them. So it sounds like a tool machine. Yeah. Okay. So Taft Pierce. Yeah. I have 2 Taft Pierce tools in the shop. One, I'll show them one day. One is a compound, beautiful 6-inch compound sign mag vise. That's a Taft Pierce. And I have my squareness indicator is a Taft Pierce. So there's a question. We'll see if we can't get somebody to answer that for you, Bud. So if anybody knows anything about a Taft Pierce tilting head surface grinder, you can contact me and I'll forward it, or you can contact Fad Radcater directly. Good question. So did we nail the grinding the chuck question? Because it really is a stopper for some people. And do you understand why putting a magnet on the wheel housing and then running it across the surface you just ground, that only tells you if your grinder is grinding properly? It does not tell you anything else. Make sure you have that in your head, because it's very important. It doesn't tell you if it's flat. So, Indiana John asked, I think, about the Taft Pierce tilting head. Do those do cup wheel grinding? I don't know the answer. See if that answer comes back. I have a couple of things I could talk about to extend my admonition that running an indicator attached to the head across the work doesn't tell you everything. There is a method. You want to talk about that? Should we talk about that? How you do measure flat? Because if you guys want to talk about it, we'll talk about it. If not, we've done a lot of talking today. While I wait for your thoughtful responses, we had talked about measuring the flatness of a PFG stone. Okay, Chris says yes. Okay, that's enough. We'll do that. So we'll talk about that next. But let me just say this out loud. We're going to do measuring a PFG stone live for flatness. But I got to get set up for it. And I think I'm going to need a camera person, because it's kind of, you got to look at an indicator that's moving around. So we will try to do that. Yeah, flat is always interesting, says KR Blodgett. Absolutely true. Fad Radcater says, how do you compensate for the wheel diameter reducing? So every time you dress the wheel, you may lose, well, depending on how much you're dressing. Don't go crazy. You might take a 0.5 off, right? So now your wheel's a different size. What do you do? So you could, oh, Warren, you'd come down for that. Okay. So maybe we'll get Warren to help out with that video or that measurement. Thank you, sir. We'll talk about it. I appreciate it. So how do you compensate for the wheel? So let's work the way. I'm going to start with my new grinder, which is a CNC grinder, and then I'll tell you what it does, and then we'll work our way backwards. So, and I was amazed that this works within microns. So this machine will dress the wheel. You command it to dress the wheel, and it'll dress the wheel. So I think I've shown this before. It has diamonds off the side of the chuck. And what it does is it will dress the wheel, and then it will take the amount it dressed, and it will deduct it from the stored parameters that it knows about the wheel. So it knows that the wheel just got smaller by that amount. And for example, I can write a program on the machine that says, you know, rough this part and then go back and dress, or actually the way you would do it is you say dress the wheel, rough the part, go back, dress the wheel, and come back in for a fine cut. And it's unbelievable how accurate that is. So on the one hand, you can do the same thing, right? So you could say, oh, I just dressed off a 0.5 thousandth off my wheel. I now know that I have to come down another 0.5 thousandth. If you're working to, you know, 2/3 tenths, that might be good enough. Okay, Warren, happy Thanksgiving. Take care, buddy. We'll see you on the other side. But really, if you're a manual, you know, if you're on a manual machine, you measure, right? So you do both. You assume that the wheel has to come down another 0.5 thousandth, and then when you go in for your post dress cut, you don't take all of it. It's just like milling. You take half of it, and then you go in with maybe your depth micrometer or whatever, and you measure. On a manual machine, that's how I would do it. On this stupid thing, it's unbelievable. You watch it do something, and it dressed the wheel twice, and you're saying to yourself, "There's no way that's going to come in." And then you get out the micrometer, you put it on there, and it's like dead on, unbelievable. So that's one answer to your question. The other answer is, well, the surface speed is also changing, right? As you change the diameter, the surface feet per minute is changing. Don't you have to worry about that? No, it's not enough to worry about. So, did I answer your question? Fad? May I call you Fad? I hope that answered it. You might say, gee, Spence, that's kind of obvious. It's kind of obvious. Okay, good question. Yeah, exactly. We're on the same wavelength. It's such a small change when you dress that you don't have to worry about all the other stuff, but do just use that number. You know, when you're grinding for 0.5 thousandth tolerance, you have one mindset, and when you're grinding for 0.5 tenth tolerance, we could talk. That's a whole other thing. Like if you let your coolant run on your part so that it stabilizes the temperature, that's when you got to do the other thing. All right, we're running long, and we're coming up on 53 minutes in, so I don't want to take too much more time. Oh, I promised to tell you how to evaluate actual flat. So the way let's say you grind your chuck in, and now you want to ask, is my chuck really flat? So you need an external reference for flat. So let me one more show and tell. Hang on. All right, so this is it's actually a parallel made by Suburban Tool, but this is 12 inches by 1 by 2. So I can qualify this on the surface plate. Take care, Fad. You are now Fad. I can qualify this on the surface plate, and I know that this is flat. And then I would go to the 25%, 75% points, and put a couple of blocks down, a couple of gauge blocks, put this down on my chuck, and now I could run an indicator from a sled to the top of this, or run the sled on top of this, touching the chuck, doesn't matter. And then as I slide along, I'm comparing this thing, which is a known flat, to the other thing, which is the question mark flat. Okay, so if I do this to my chuck, and I walk away and I say yes, it is as flat as I could measure, then you've measured flat. That's how you do it. So then the question is, how are you sure that this is flat? And the answer is that there's a bunch of ways to go about this. But if I take my micrometer out and I measure with my micrometer along this, and it is parallel, and remember, I've set this thing up on a couple of equal blocks, which I measured with my micrometer. All I do is I flip this over and I repeat my measurement. Because if this thing has a smile in it, yet it's parallel, in other words, if this thing is bent, then the two measurements are going to, if you average them out at each point, they're going to average out, and you're going to get rid of that, and it's going to be flat again. So that's one way. There's probably a dozen ways to do it. So that's how you would measure if your chuck is in fact flat. Okay? Last chance for questions, and then we're going to disappear. And we'll see you guys after Thanksgiving, American Thanksgiving, which is the 25th of November. For you guys just joining us, you're right at the tail end. We're gonna punch you out of here soon. All right, I don't see any questions coming in. What would that big parallel be called? It's called a big parallel. I believe these are sold by Suburban Tool as parallels. Okay. You can make one, and you can even scrape one in. So you could take. Yeah, we are cooking. I will be helping, and yes, we'll be celebrating here for Turkey Day. You could make one and scrape one in. I also have a scraped in flat. You could use that also. The advantage of a parallel is the flipping it over trick. That's an advantage. Okay. Otherwise, it'd be kind of the same. If you use why am I not thinking of the word? The parallel, the scraped in one, you only have one surface. If you have a camelback, that you only have one surface. It's a little harder. You have to get it up high and then measure underneath it. So the bottom line is, the summary statement with what I'm going to conclude with from that most excellent question today is a measurement from an indicator that is attached to the wheel housing and touching either the work or the chuck only measures whether or not you copied the ways. That's number one. Hey, Adam. And number two, if you want to measure true flat, you need an external reference. And that's why I brought that up. Sorry we missed you earlier, Adam. We were talking about you, though. In fact, Adam, you are here just in time for us to call it a day. I talked about you, I think, right at the beginning, because we talked about the roundels. Did you have anything you wanted to report on those guys before we break this fabulous meeting? Yes, we actually spoke about you highly. Every time we mentioned your name, we bowed a little bit. All right. Well, Adam's been abusing them. Well, I gotta close this down because we're going so long here. Yeah, the abrasive seems much tougher. Is that a plus or a minus? Or is that it depends? All right, so Adam is still approving of the roundels, and that's good. So I did put them up on the website. So if you guys are interested in the little guys, a pair, of course, just like the big 4-inch rounds, except in these little cute little 2-inch rounds. They're up on the website. I have they're so cute. 3 sets available to ship right now. And they're in the normal lineup. All right, it's 2 o'clock. With that, I'm going to say best wishes to everybody. I hope everybody has a great Thanksgiving and a peaceful one. And I hope everybody has a chance to spend some time with, and at the very least, communicate with family. And we'll see you guys after Turkey Day. I haven't looked at a calendar, but probably next Sunday is good. I kind of like this time. This is 1 p.m. Eastern Time, 18 Zulu, I think. So, yeah, take care, Indiana John. So we'll try to do it next Sunday. Have a great holiday, everybody. Stay safe. And we'll see you then. Cheers.